So, hello everyone. So, in the last lecture we have seen what is Fourier transform and how it is we have obtained Fourier transform from Fourier series, and today in this lecture we will see what are different properties of Fourier transform. See, basically the Fourier transform when we have seen, it was basically a integration function with the help of exponential, which are having something like this, that f omega, it was f omega is basically ft. This was the function. So, here if every time if we so what we have to do, we will have to keep ft and we are required to integrate this. So, it will take a lot of time, or it will be very hectic task to calculate this every time. So, if we have some properties or as a tool, so which will help us in getting the result in a faster manner. So, we will see what are the properties and how it is very useful in calculating the Fourier transform of some given function. See, so this is basically what two part I have told you. This is what this was synthesis part. This means what, when you are required to find the network, that is called synthesis part, and we are required to find the response, that is called as analysis part. This is basically analysis part. So, this is basically Fourier transform minus infinity to infinity x t e to the minus j omega t dt, and this is what basically what Fourier, this is also called as what synthesis, also called as what inverse Fourier transform or IFT. It is basically synthesis part is also called as inverse Fourier transform. So, this is the first property. So, same thing I have written here, synthesis analysis. So, see what is the basically the first property is the property of linearity. What is meant linearity? The property says, suppose if I am having some xt function and some yt function, and we know the Fourier transform of xt as x j omega or yt as y j omega. See, x j omega can be considered, somewhere it is written, at some books it might be written as x omega. So, both are same, means differentiation. If you can say, if xt is the function, then somewhere they write Fourier transform xt as x omega. Also somewhere you will find it xt Fourier transform x j omega. So, don't get confused, both are same thing. So, here it is they are writing j omega as the Fourier transform for. So, okay. So, here you will see. So, if you know the Fourier transform of xt is x omega and yt is y omega. So, if we have axt plus byt as input, so we will get ax j omega plus by j omega as the what output. So, this is basically a what linearity property. If input is multiplied by a, so our output is also getting multiplied by a. The response remains same, only the amplitude changes. This is basically the proof. How we will prove it? See what changes will come. See here a, and here it will come b. So, if we, from this function we will take a as a common, and it will become like this. This is basically j omega and this is basically y omega. So, this is how we can prove this as that linearity property gives us the same result, only the output get multiplied by the individual amplitudes of input. Here if xt was multiplied by a, the output will also get multiplied by a. Then we are coming to second property, that is time shifting property. So, what is time shifting property? In time shifting property, see, if I delay the input by t naught, second or by some duration, then what will happen? Then if delay the input by t naught, then the output will have some function as addition function as e j omega into t naught, e j omega by, here it is writing, it written t naught, it is t naught, it will be replaced by e minus j omega t naught. So, see, so how we will prove it? See, suppose this was the given function, and suppose the input is delayed by x t minus t naught, then x is also input is t minus t naught, and here you will write. So, replace t minus t naught by what? Some function delta. We are replacing t minus t naught by some function delta. So, t becomes now what? Delta plus t naught. Put this value here. So, you will get it like this, x delta j omega delta plus t naught d omega. So, what is the result? See here, now suppose expand this, we will get x delta e to power minus j omega delta into E minus j omega t naught into d omega. This will get under integration now. So, as you can see, this is what basically variable, and this is now this becomes what, a constant function. So, this can be taken outside the integration. So, this becomes e to power minus j omega t naught minus infinity to infinity, and here it will come as x e to power minus j omega delta d delta. So, this is what basically x omega into what, e to power minus j omega t naught. So, what happens, see, x j omega into e to power minus j omega t naught. So, here what is important thing, this means that time delay in the input side is equivalent to the linear phase shift in what, output side. That means, suppose if you are delaying in time in the input side, and if you are using Fourier transform, that means in Fourier transform you are going to where, you are going to frequency side. From time domain we are moving to frequency domain. So, that means the delay in time domain is equivalent to change of shift or change in phase shift, or there is phase shift in frequency domain. That means a time delay is equivalent to frequency shift when you are using Fourier transform. So, this is what is ascertained, or it can be concluded from this time shift property. Here it is written, phase shift is proportional to frequency. Okay. Now, next point is time scaling. What is time scaling? When we multiply or divide time by some quantity, see x a t, or if you make x t by a. So, this is basically called what, time scaling. So, what will happen if we multiply some constant a into time. So, what is the result? The result, this is basically the result is 1 upon a x j omega by a. That means if it is a, if even x, if it is minus a t, still you will get the same result in magnitude, it will become, because 1 by a x j omega minus a. So, here you have to remember, often students forget this modulo sign here, they make it as, if there is minus a, still you will have magnitude, in magnitude you will have minus, you will not have minus a, it will still be a. So, this is how we can prove this. Assume a is greater than 0, see a can be, is positive, basically what we are discussing today, a is positive. So, if we replace a by what, delta a, or a t by a t, see what will happen, you write a t j omega t, replace delta by a t. So, again what we will get, see here x delta e to power minus j omega by a delta. So, here as it is constant, you will come outside integration sign, and here you will have x to the power j omega by a. See here, because this is what, now this is whole term is now j omega. Now, omega it now basically omega by a. So, what is happening? That means scaling in time is also getting change in frequency. Earlier was what, delay in time shift, delay in the time domain was equivalent to phase shift. Here what you say, scaling of time is basically what, change in frequency, delay. So, 2 point you must remember, time delay in input side or time duration side is equal to phase shift, and time scaling is basically equivalent to frequency change. See here, frequency is changed from omega to omega by a. So, remember this property also. Here third property is basically time reversal. See, in time reversal is one of the different form of what, time scaling. How it is similar to time scaling? See, suppose is place of a you keep it as minus 1, on the place of a in time scaling, if on the place of a you write it as minus 1, then it become what, time reversal. So, what change you are going to get? You are going to get same thing, only what will happen, I have told you, here a will remain, magnitude is under modulus, it will remain same, only it will change, minus sign will come here in the time domains. That means time reversal means here frequency is getting multiplied by minus sign. Okay. So, remember this, or also one of the modified form is, so here you will get same thing, only angle we change. So, this is basically can also be written as x minus t is equal to x minus j omega, and this is equivalent to what? X star j omega, x star j omega. So, remember this form. So, this is time reversal form. This is what I have told you in the special case of what? Time scaling. Time scaling, you have to put a is equal to -1, and that becomes time reversal. Again, this is the another property. If you multiply the input or input in with some time constant, sorry, time constant I am saying, with some time power, let it be t1, t2, t3, anything, then how your output is going to change. Number of time, what is the power by which you are multiplying t with xt, same number of differentiation you have to make with what? At the side of output, at the side of Fourier transform. So, if xt is equal to 1 upon t xt e to the minus j omega t, then it is written as dx j omega by d omega. So, differentiate this first one time. So, you will get what is, you can see, you get result as e to the power dn by d omega j, j to the power n. So, suppose if you take some example, we will try to solve. Suppose you are having, so see how this result is useful. Suppose e to the power minus at, just now I have e to the power minus at ut. So, just now I have told you that e to the power minus at ut, what was the result? In the, we have discussed Fourier transform for this, what I have discussed, it was 1 upon what? A plus j omega, just now we have discussed. Now suppose if I am required to find t, if someone asks you, suppose this is xt, e to the power minus at ut, and someone asks you find the Fourier transform of t xt. So, if you go by the conventional method, so what you have to do? You have to write t, you have to write e to the power minus at ut, and again integration minus infinity to infinity e to the power minus j omega t dt. You have to integrate. So, it will take a lot of time. So, what you can say using this property of multiplication, what we will do? See, we know that if something multiplied by, see, so here t to the power, what is t to the power 1? That means how you can directly write result as j to the power 1, and you have to differentiate this result by what? First one time, means d 1 upon a plus j omega by d omega. You have to differentiate this result by d omega. So, what result you will get? You will get basically this as 1 upon a plus j omega square. So, this is basically by using the property we can easily find out this. I think is not visible. So, when you differentiate 1 upon a plus j omega, you will get, if you differentiate this by d omega, you will get 1 upon a plus j omega whole square with a, so this is the final answer. So, by using the property you can find it easily. Next is basically multiplication by a computational exponential. So, what we have done? Earlier we have multiplied this input by some time function. Now, what we will do? We are multiplying the input or the signal using what? Some exponential, complex exponential. So, what is the result? The result is x j omega minus omega naught. So, j omega minus omega naught. See. So, suppose for now how we can solve this? Suppose just now we have seen x t as e to the power minus a t u t, and for this Fourier transform we are getting as 1 upon a plus j omega. Now, suppose if we are required to find the Fourier transform of x t into e to the power j 2 t, or if you are required to find the of j to t, or so what we will do, what will come in this. So, you are getting, I am telling that x t, for x t we have got e to the power minus a t u t. Now we are required to find that what is the function of e to the power j 2 t. So, using the property we can say if some function is multiplied by exponential complex, we will get x omega minus what? omega naught. So, omega naught is here, omega naught is what? Omega naught is equal to 2. So, here 2. So, replace in this result you will get 1 upon a plus j omega minus 2. So, this is basically the final result. Same using this property itself, using this property only, we can easily find out, see, using this property we can find out the Fourier transform of what? Xt into cos omega naught t. How? See, I have told you from formula that cos omega naught t is basically written as e to power j omega naught t plus e to power minus j omega naught t into 2, and similarly sin omega naught t is written as e to power j omega naught t minus e to power minus j omega naught t upon 2j. So, this is how we represent cos omega naught in sin omega naught in exponential complex. So, what you have to do, if you are required to find the exponential the Fourier transform of x2 into cos omega naught t, just replace cos omega naught t by this result. Once you replace it by this result, so you got x2 into e to power j omega naught t, then xt into omega. So, by using this multiplication by complex exponential formula, you can write here, see, as it is, see, remember this, if omega naught, it is omega naught, if omega naught is positive, delay, then here it is negative, and if here it is like if minus j omega naught t, it will become x j omega plus omega naught. So, see, here it was x j omega naught, it was positive, so result is negative, here result was negative, so we got it as positive by 2. So, using this multiplication property, we can easily find the Fourier transform of xt cos omega naught t or xt sin omega naught t, xt cos omega naught t or xt sin omega naught t. Okay. The second another property is differentiation in time domain. Suppose if you are having some differentiation in time domain by nth order, if you differentiate this input by nth time, nth order, then the what will get the result as j omega n as x j omega. Output will get e to power n into x j omega. So, this is what very simple, you can easily remember. The order of differentiation is same to the power of n. Similarly, integration, what we do? Integration, suppose this is the integration of a time domain minus infinity t, what will happen? It is 1 upon j omega, just remember this, x upon j omega 1 upon plus pi x 0 upon del omega, pi x 0 upon del omega. Again multiply, so this is a very important property, you must remember. This is very much useful when we are required to find output of any given. Suppose we are given, suppose later you will see you are given Fourier transform of one signal, and again you in one domain, and you are required to find the output of that signal in frequency domain with some other input, then that in that case this is very useful. So, what is you have to remember here is the multiplication in time domain, is equivalent to convolution by 2 pi in what? Convolution by 2 pi in what? Frequency domain. Okay? Means multiplication in time domain is equivalent to convolution in frequency domain, and similarly next you will see convolution in time domain is equivalent to what? Multiplication in what? Frequency domain. So, remember both the relative handle xt into x1t into x2t, I am writing both the property together, is equal to 1 upon 2 pi x1 j omega convolution x2 j omega, and here and write xt or x1t into x2t is equal to or x1 j omega into x2 j omega. So, this both result you have to remember. See how we can prove this, we can easily prove this. See, just as how you know how we write convolution, this is convolution, we delay the time by the some factor delta, and just place it in the integration form here, and you see. So, now you get the combination of x delta into h t minus delta e to minus j omega t dt d phi. So, This is how you derive it. You can easily derive it. Just write this convolution form and expand it, and while expanding, and at last replace this by minus delta, and you will get the result. So just remember the final result. See the proof of property is not required. You are just required to remember the property. You are not required to prove the property. You just remember the result, so that you can directly use it while solving the problems. Okay. So another is Parseval theorem. So what is Parseval's theorem? See, Parseval theorem is basically when you are required to find the energy of a signal. Suppose someone asks you to find the energy of signal. So you know the formula for finding energy of a signal. This is what suppose how you can find the energy of a signal. So see, basically if you remember xt square dt minus infinity to t. This is basically what formula for finding the energy. So suppose you are in time domain. So this is formula for finding the energy of any signal. But suppose you have the result in x omega form, or you have the Fourier transform of any signal, and by using the Fourier you have the Fourier transform form. You do not have the time domain signal function. You do not have the form the signal in time domain form, but you have it in the what x omega form, or it is in omega form. So in frequency form. So if you are required to find the energy using this form, so this is what here you get the result at what the x energy in time domain is equal to 1 upon 2 pi x omega square into d omega. So this is basically what the conversion in frequency domain. So energy in time domain is equal to 1 upon 2 pi energy in what frequency domain. Suppose, for example, if you take one example, suppose it is given example you take, it is given a suppose this is given. What is given? The frequency response of Fourier transform of a signal is given. If you are required to find the energy of the signal. So if you do not have this property, what will you are required to do? First you have to convert this into what xt form. Then after you get xt, you will do what xt square dt minus infinity to infinity. This you will require to do in order to find the energy. But since now you know the Parseval theorem, what you will do? You will directly use this result. And you will write this as 1 upon 2 pi integration what x omega square d omega. So basically what will result? You will get 1 upon 2 pi. What is the area of a square? It is 4 into 4, 16 into dt. What is dt? What is the interval of the signal? Minus infinity to infinity. So this signal exists only for minus 2 to 2 seconds. So what the result you will get? dt d omega. So you will get here as 1 upon 2 pi 16 into 4, 64 by 2 pi, that is equal to 32 by pi. You will get it as 32 by pi as the result. So this is very easy. You can easily find the energy by using the Parseval theorem. So now next is duality theorem. So what is duality theorem? See, duality theorem says, see, as per duality theorem, it says if xt gives you xj omega. Okay. So now suppose if xj omega, and now if you have some input in this form, j omega form, this form, and so convert this into jt form, then after this you can write it as Fourier transform as x to power minus omega 2 pi del 2 pi x to power minus omega. So you can easily see, let us understand it from example. Suppose I take example as what? Okay, take one example. See, suppose we have one question as you are required, given is xt is equal to 1 upon a plus j t. Suppose if you are required to find the Fourier transform of this signal a plus jt. So, see it will be very difficult by finding using conventional method. So, see how you can solve it using this using duality theorem. What is that say? Just convert this xt into x omega. So, x, what is x omega? X omega will be 1 upon a plus j omega, okay, okay, convert into x omega. So, you will get it what x t converted to x omega will become, see we have directly what you have done, replace t by omega. Now, now see what does this for what input you will get this as a Fourier transform. If you remember for what input we are getting 1 plus a j omega as Fourier transform. So, if you remember for e to power minus a t u t we were getting 1 upon a plus j omega as Fourier transform. So, replace this, so this is, so and now replace this by what? Replace this by what? This formula 2 pi e to power minus a t. So, what was the what is the result? I have told you, just remember x t replaced by x omega. Now, see for what function you have got this a 1 plus a by j omega as result. So, now you have, so you remember you get e minus a t u t. For this input you are getting 1 by a plus j omega as a result. So, now this is finally, so what we will do, we will write finally u t minus omega. So, here what was the t? So, you write e to power a minus omega, just you have to replace by minus omega. So, again write like this and replace t by omega 2 pi e by omega, okay. So, this was the final thing. In next lectures we will see some more problem because in the next, because now that time is close. So, in next lecture we will see more numericals on duality theorem, because see duality is the very important tool using for solving any complex time domain form into exponential form, because see as it is exponential e to power minus a t x t. So, any function which is of exponential nature you can easily solve, but suppose if x t comes in this form, or if x t comes in a form of modular or some x to the power domain in the domain form or modulus form, it will be very difficult to solve this, okay. So, in next class we will see how you can easily use duality to find the output of some very difficult signals, okay. Thank you.